Mr. Dhruv PARPIA.
Thank you so much, Gabby. Good afternoon, everyone. As Gabby mentioned, my name is Dhruv PARPIA. So I've been with Amazon Web Services for about 2 years now, and in that time I've met with a lot of game companies, and there's a lot of traction towards moving towards Amazon Web Services. And this is really just an introduction as to how to get started with the platform and what we see as a general use case for Amazon Web Services as well. So what's in it for me? Basically, we're going to talk a little bit about mobile game trends, the core game backend, scaling out and how you can do that effectively and efficiently on the platform, push messages, and analytics. So just to start off with, these are just a few of our gaming customers right now. Supercell, really awesome guys. Gumi here in Singapore as well. Ubisoft, and a whole host of others. So let's talk a little bit about the mobile game landscape for a second. Everyone knows Fruit Ninja as well. They actually run on us as well. So everyone knows that majority of the time, free-to-play is here to stay. It's the trend that's really picked up and is being basically the trendsetter, I should say, in the market space. With free-to-play, a lot of in-app purchases as well. And then you have the long tail where you're just trying to keep the people in the game as well, right? You also have cross-platform, iOS, Android, stuff like that going on as well. And then, of course, from there, if you have a successful game in a certain region, you want to go global with it as well. And of course, after that, you want to retain those users, because when you retain them, you get revenue. This is the source is Gartner for this projected mobile app revenue. One thing of note over here is that we can see that paid apps are kind of tapped out. You can see that there's a clear trend towards moving to in-app purchases and advertising revenue, and that's always going to keep scaling up. It's not stagnant over there. But towards the end of this year, we're going to see that going forward, paid apps will not really be generating more revenue. So a few features of online mobile games, right? Obviously, you have your social login. And with that social login, you're going to have friends lists, which kind of get converged so you can see who's playing what game where. And of course, with that comes leaderboards. And with the leaderboards, you want to know who has the high score. You know, did Fred beat me in, in Clash of Clans today? I want to go and raid his village. So, push messages becomes really important there as well. Of course, then you have content updates. You might have a Christmas-themed pack or a Halloween-themed pack or something like that, very specific to that particular time. So you've got that as well coming in from an online feature set. And then, of course, the last bit being analytics of the platform itself as well. So once you have users, how are they using the platform? How are they consuming things within the platform? You want to analyze that and ensure that you know where that's going next. So one of the big benefits of using Amazon Web Services is having the ability to pay as you scale. You do not need to predict where and when you need to scale your platform. So in a traditional environment, if you look at this, usually what you do is you'd say, I need about 4 servers to handle what I expect is my load. But what happens if you suddenly see a massive spike, or you suddenly see a lot of users come in and make the game go viral, right? How do you handle that load? In traditional terms, you're probably going to have unmet demand, upset players, missed revenue, right? And then you're going to scale out, handle that again, but then again, you may have a curve which impacts your game. With Amazon Web Services, what you can do is you can scale as you require it, right? If you need 10 servers at any point in time, add those 10 servers. If you want to remove them because your demand goes away, take them out, right? So scale when necessary and however, as much as you need as well, right? So this is just a small example. This is DevSisters. So what happened to them was that within 24 hours, they scaled from 2 instances or 2 servers up to 60 and then back down to 2 again. All of this was done in the span of 24 hours, right? And this is just to manage their peak demands, right? So this can be done on a very granular level, and you can ensure that your users will always get the best experience possible. The other ability that you get with Amazon Web Services is the ability to go global in minutes, right? So we have a standard API across all of our regions across the globe. We have 10 different regions that you have access to, right? I think there are 9 that are shown on the board here, but the 10th region that we have is in China, right? So basically, you have access to all of these regions. They all have the exact same API, so you can launch servers wherever you want them, okay? Again, a good example of a customer that's using us really well is Supercell. They launched Clash of Clans and Heyday on the platform as well. Right, so let's get into the crux of the matter. Let's talk about the mobile backend technology, right? So majority of the times, what we see now is that they're HTTP based, right? There are certain situations where you're going to have a persistent open TCP socket, but that's really for games like first-person shooters or MMOs and stuff like that. But with traditional mobile games, it's usually HTTP based. You open a connection, you talk, you get some data, and then you stop that connection. You're obviously going to connect into external social APIs. You're going to talk to Facebook, you're going to talk to Google, you're going to connect all of those together and have that within your game. You're going to have a save state, right? You're going to have the last point at which a person was accessing the game. You want to know that because they want to continue on from that point as well, right? Obviously, you're going to have your standard database for logins and transactions and the regular stuff that you need. You're also going to have a static data store for your image assets, your DLC, anything that is basically a static image or an HTML file. You want to have a static data store for that as well. And then, of course, like I mentioned earlier, you're going to have mobile push. And the last one, of course, is analytics. So let's talk about building that on Amazon Web Services for a second. So we have the mobile app, right? What you can do is you can start with by choosing a region, right? So let's say we use Singapore as the region for this example. Like I said, we have 10 globally, but we do have one in Singapore as well. So you can start with Singapore. You can use what we like to call availability zones, okay? So availability zones are multiple clusters of data centers that are interconnected with each other that give you a low latency, low cost connection between them. So think of them basically as separate data centers, right? So if one was to fail, the other one would still be able to serve your game. But since you're still starting up, you're still in a dev mode, you don't really need to leverage that at this point in time. So what you can do is you can use one availability zone, okay? You can launch an instance. EC2 is what we like to call that, or Elastic Compute Cloud. You can launch that in Linux or Windows, and then you can drop your app server code on that, right? That would run your actual PHP app or Node.js or whatever it might be. Behind that, or sorry, in front of that, you might want to attach an Elastic load balancer, okay? Now you might be asking yourself, why would I attach a load balancer for one server? It just doesn't make sense, right? So what we're trying to do over here is make sure that you take best practices into account when you're building your game. The Elastic Load Balancer is very handy for you to have even at one server, is because that when you do expect to expand the amount of servers you have, you don't have to change your code when you're going live, right? You're already taking those steps in place to make sure that you go live, you don't change your code. It's just available and ready to go, right? So it's always wise to have a load balancer in place. There's no real additional cost to it. It's basically the amount of traffic that goes in and out of the load balancer is what's charged for. And with dev, you're not going to have that much traffic going in and out, okay? For your database, you can use something known as RDS, which is our relational database service. This is a completely managed database service for MySQL, Postgres, Oracle 11g, and Microsoft SQL Server. So you have full control from a database perspective, but we manage the backup, the patching, all of the tedious tasks that are involved with the database. We handle that for you. We also take 5-minute snapshots of your data, so if at any point there is a failure, you can just load it up again and it's available for you, okay? If you don't want to use RDS, you can also launch an EC2 instance with whatever database you want, okay? And of course, from that point, you'd want to have your social APIs connect into your platform as well, right? And they can talk back to the EC2 instance. The EC2 instance, like I said, is just a server, okay? let's scale it out now. Let's say we're going into version 1 of the game. It's actually going to launch within a region, right? So we've got that initial setup, and like I said, what we can do from there is we can add high availability. This is extremely important, right? We don't want to ever have a failure to an application that's just about to launch. So let's avoid the possibility of the infrastructure itself failing. So let's add a secondary availability zone, a second instance, and connect it back to the main SQL server, okay? What you can also do on top of that is for your database, since that's actually physically in one availability zone, we have the ability for you to launch what we call multi-AZ mode, which basically has a secondary database which is exactly the same. It's got a block level replication of the data in the other availability zone. And if there is a failure to the main availability zone, we just switch the DNS entry for you, right? So it points to the other database. So there's no actual change to the application, it just keeps running. Again, you can also do that in a DIY state. So if you wanted to run 2 different servers in both availability zones, you could do that as well. We're also going to add S3, which is our simple storage service. This is a great place for game data and static assets, user-generated content, and where you eventually want to store your analytics logs as well. Right? It's extremely cheap and highly, highly durable. It provides you with 11 nines of durability, which basically means you could store 1 million objects on the platform, and you may lose 1 in 100,000 years. Supercell, again, awesome guys. They use all of these different things that we just spoke about, right? And it's not just about Supercell. It's also about some of the larger brands out there. So Uncharted 3, actually, so Naughty Dog runs their game servers for all of their games on Amazon Web Services as well. So it can be from a mobile game all the way up to a AAA title. They're all looking at using the platform. So we've scaled out, right? We've got a highly available architecture set up. Let's talk about now really scaling out where your application has gone viral, right? So what you can do is you can start adding what we like to call auto-scaling groups. So the example that I used earlier of Dev Sisters, they have what we like to call auto-scaling groups, where basically based upon a metric, you will scale in or out as far as how many servers you have running at any given point in time, right? So you may have to start with 2, right? But let's say at the peak time in the day, you might need 60, you might need 80, you might need 100, right? Auto-scaling gives you that ability to match whatever it is that you need for that point in time. You don't have to think ahead of schedule, right? So based upon a metric, let's say number of users, right, is the metric we're using. You can raise an alarm. That alarm sends a message to auto-scaling. It adds 2 more servers. You can handle your users as they come in. You don't have to really wake up in the middle of the night and start loading up servers or thinking about how you need to handle this. It can be handled for you, okay? And then on top of that, because you're starting to see more and more users, you may want to think about adding a cache layer. You can think about using memcached, or you might want to think about using Redis as a caching layer in between. You can do that using another service of ours called Elastic, which is basically managed Redis or managed memcached, or you can do it yourself. You can just launch a Linux instance, run it on EC2, and run memcached or Redis yourself as well. Yeah? The choice is yours. You don't have to use our services. You can use whatever it is that you like. And then in front of your S3 assets, what you can do is you can use CloudFront. So CloudFront is our CDN, or Content Distribution Network, right? This is where you can start accelerating the content to locations closer to your end users, okay? So let's say you have a ton of users in India or in Taiwan who've really suddenly picked up the game. The awesome thing for you is that you can actually cache those assets much closer to them with lower latency and higher download speeds so that they can keep playing the game even faster, right? All of those assets will be much closer to them. So we have over 50 locations across the globe where you can access CloudFront. We have edges in Manila. Well, I can cover Southeast Asia right now. Manila, 2 in Singapore. We have them in India as well. We have them in Taiwan, in Hong Kong, in Korea. So a lot of the large gaming populace is handled through CloudFront. So I'm going to move on to databases for a second, but just wanted to point out Halfbrick because they use the next services that I'm going to talk about, right? And this is a problem that most gaming companies face, is that writing to the database is extremely painful, and you have a lot of data that needs to be written at regular intervals, especially when the game is popular, right? Games are write heavy, right? So you can't really cache that much data because of that, right? And majority of the time it's key value, right? Users come in, you want to know exactly what their level is, what they purchased, and stuff like that, right? It's all based upon that key being the username or whatever it is that you identify them by. It's usually fairly binary data, right? It's either on or off. Do they have this? Have they purchased this DLC, or have they not, right? Majority of the time it's binary, right? And most of the time we find that the database is the bottleneck, right? So what we can do for that is we can move to something called DynamoDB. DynamoDB is a NoSQL data store, okay? It's fully managed by Amazon Web Services, okay? And it's highly available. We handle all of the management of the platform for you, right? Basically, all you have to do is either put or get to it, and they're all based on key value, okay? It follows the concept of provisioned throughput. So, like I said, it's a completely managed service. So you actually have only one control point. You decide how fast you want it to be. Do you want it to run at 10 IOPS? Do you want it to run at 1 million IOPS or somewhere in between? You can choose, right? You're in full control of only that one parameter, how fast you want it to be, okay? You have the ability to also have secondary indexes with DynamoDB as well, okay? So Rovio, Halfbrick, all of them use this as a platform. So let's move on to messaging and queues really fast, okay? So we have another service called Simple Notification Service, okay? This is where you can actually have HTTP push messages go through. You can have SMSs in the United States, and you also have the ability to send mobile pushes to Android devices and iOS devices. So if you look at the diagram, so we're going to add an HTTP endpoint for the Simple Notification Service, and you can push it from there out to your multiple different mobile devices as well, right? We also have another tool called CloudWatch, which takes care of the monitoring and alerting for you. So what you can do is you can actually have CloudWatch sit up there and watch and see how your servers are reacting, right? Based upon, let's say, you're seeing heavy load come in at any given point in time. You can launch that alert, right? It can come to you on your phone through an SMS or a mobile push, right? And then you can decide what you want to do. Do you want to go to the pub because you don't know what to do with it, or maybe you do something about it, right? The choice is really yours. So moving a little bit astray from alerting and messaging for a second, let's talk a little bit about SQS, or our simple queuing service, right? So this is where you get to really build out a large platform where you can have asynchronous tasks, right? So a lot of the times you have background tasks that are running quite regularly, or you have avatar resizing or score processing that happens quite often as well, right? Now this can start to bog down your platform if you're running it on the same set of servers. What you can do with SQS, which is that little icon over there, is you can have a secondary set of instances just come up if there is something in the queue, right? It comes up, it processes whatever it needs to, and then it goes away, okay? You can choose to do that however you feel necessary, right? So you can send your background tasks, the avatars that might come in by the users, all of that stuff could just keep pumping into the queue, and based upon the queue, you can resize it and then handle it off from there, right? You can even send a notification from there saying, hey, your avatar's been resized, it's now available here, or hey, your score was processed and now you're at the top of the leaderboard, stuff like that, right? You can completely abstract that from your main game servers. The other thing you can also do with SQS is look at CloudWatch again, right? So you can manage your spin up of servers. You can manage whatever it is that you need to take care of, if you're heavily loaded with the amount of servers that you have right now, stuff like that, you can handle SQS. SQS can handle it for you where it just launches all the instances, and then you can just get a message at the pub and everything's okay, right? So another company that uses autoscaling really well is TinyCo. They also do something with our analytics platform, and that's the last bit of my talk. So this is, I think, really, really cool, right? So Dilbert kind of sums it up. If you don't have proper analytics, right, you're just going to come up with a number. So to start with, a lot of companies should truly look at off-the-shelf analytics. They are really, really powerful to start with and can give you an edge when you're looking at what next needs to be done with my platform, right? You don't need to start with this big system that's going to cost you tons of money. You can start with a free platform. Think of Tableau or Pentaho as the two options that you have. Pentaho being open source, and Tableau has, I think, a free version available for the desktop as well, right? So you could start with that. It's really easy to integrate. They have some pre-baked reports as well that you can leverage. Obviously, there are some rate limits with that stuff. And there's a retention window as well, right? You can only retain it for, I think it's about 2 weeks before they remove that data. And then, of course, the last and the hardest bit is the data lock-in, right? You're always going to get locked in with some of these analytics platforms. So when you're at the scale where you need to start looking at analytics really, really heavily, right? Your game has reached a certain level. You can start by using something we call Elastic MapReduce. Elastic MapReduce is a completely managed Hadoop platform, right? It's a great place for you to pass your logs, for you to clean up some data. You might have excess data in there in the logs. You want to clean it up and just make sure it's ready and visible for usage. And then, of course, you can aggregate your data in there as well, right? So you can grab your data from S3. The ideal location to store all of your logs is actually in S3 because, again, it's an extremely cheap and highly durable platform. So you can keep your logs in S3, move them into Elastic MapReduce, and then what you can do from there is you can pump that data after you've managed it over there into what we like to call Redshift, right? Now, Redshift is basically a data warehouse solution that's provided by Amazon Web Services. The really cool thing about it is it's completely column-oriented, right? And it'll respond to SQL-like queries, right? So after you've reduced your data, and you've crunched it to the point where it's just really, really perfect for consumption, you can push that data into Redshift, and then you can just run standard SQL queries against that, right? And then you can, of course, store that data back into S3 once you're done with that solution as well, right? You can also have DynamoDB or S3 push the data into Redshift as well. So let's just look at this for game analytics for a second, right? So you write the files on the device, right? You're collecting the logs from each of your devices, and it might be just when they played, what level they're at, what was their high score, and their last save state, right? So stuff like that just keeps getting written on the device. You can push that data back into S3, right? From there, you can process it into Redshift, okay? And then you can point a GUI tool, whatever it might be. It could be Tableau, it could be Pentaho, it could be something more expensive, right? The choice is yours, or you could have built your own. You can point anything you want to at Redshift because it's a standard SQL operated query. You can also collect your server logs, right? You can periodically upload those into S3. You can clean those up if they're not, completely clean for Redshift. It might have excess information. And then you can stick that into Redshift as well. And from there, exactly the same thing happens. So you get this one pane, glass pane view of all of your analytics. How are your servers performing? How are your games performing? Everything that you need should be in one place, right? And you can get that ability with Redshift as well, right? So I know that this is the last talk of the day, so I'm going to wrap it up really fast for you guys, right? So free-to-play is here to stay. We want you to start small and then scale out from there. Think about using DynamoDB, right? It's a really, really efficient and awesome tool. Use S3 with CloudFront. If you're not going to do anything else with Amazon Web Services, think about using S3 and CloudFront, right? So just so you know, CloudFront provides you with 50 gigabytes of data free, outbound, right, to your end customers. So you can use it for free, try it out. You'll get your data out to your customers way faster, right, and it'll be better for your customers. Think about using SNS for mobile push, right? Again, you don't have to worry about communicating with either Google or the Apple push notification system. We handle that for you. It's just one API call, okay? And then think about using SQS and Elastic Cache to scale as well, okay? And the last thing and the most important thing is we want you to focus on your game, okay? That's it. Thank you so much.